Hello everyone, welcome to the presentation on applications of machine learning. Throughout this presentation, we'll see how machine learning has become a central pillar in a technology that interacts with the world, and also we will tell you how wide-ranging and impactful those technology are. So here's the team. I, Dhruv Jain, and my teammate Anurag Nigi have collaborated on this presentation to explore how machine learning is transforming the way we live, work, and interact with the modern day technology. So here's the table of contents. We'll start with a brief introduction to what machine learning is and why it matters. Then we'll dive into specific use cases like cybersecurity, healthcare, smart cities, IoTs, that Internet of Things. Next is banking and finance, and finally we'll talk about predictive maintenance. Each of the section includes real-world examples and case studies to help and illustrate machine learning's impact on these technologies. So let's begin with the general introduction to machine learning. Next slide. So machine learning is a type of artificial intelligence that enables system to learn and improve from experience without being explicitly programmed for every task. This it's a game changer across industries. Imagine systems that become smarter over time just by processing more data. That's what machine learning does. Whether we are talking about diagnosing diseases, predicting financial trends, or managing city traffic, machine learning helps us make better, faster, and more data driven decisions. It means decisions are mainly based on data, not based on gut or instinct. So, in today's digital era, understanding how machine learning is applied can give us a competitive edge, and that's what we'll talk on in this presentation. So, let's begin our introduction with a very relevant field, cybersecurity. So, machine learning enhances cybersecurity in powerful ways. First, there is anomaly detection. Machine learning models can learn what normal behavior looks like on a network and then raise flags when something unusual happens, even if it is a completely new kind of a attack. Second is AI assisted threat intelligence. Machine learning algorithms can analyze millions of data points from different sources to identify patterns in cyber threats and alert us in real time. Now we'll talk of a standout example of Darktrace. It is a company that uses machine learning to build self-learning cybersecurity systems. These systems adapt constantly to evolving threats without needing human intervention in every step of the way. Means at every step they have implemented machine learning. This has decreased human intervention. So now we'll see how machine learning fits into a cybersecurity system. Now there's a diagram that shows a complete workflow starting from various sources like network activity, database activity, application logs, and user actions. All of this raw data is collected and stored securely. First, in the top left, we can see there is data sources. This is where everything begins. These are the systems being monitored for suspicious behaviors, and these includes network activity, database activity, application activity, and user activity. So we have four things. First, we'll talk about network activity. Tracks. Basically, in this machine learning algorithms, we track traffic like IP connections, bandwidth usage, and unusual communication patterns. Second is database activity. Here we monitor changes in databases like insertions, deletions, and suspicious queries. Third is application activity. Basically, we look into how software is being used. For instance, if a vulnerable app is exploited, we'll raise a flag. Next comes user activity. We observe user behavior such as login patterns, access times, and command usage. All these logs act as raw input for our system. Now, second comes data collection here. All the logs and events from the above sources are aggregated into a centralized collection system. This ensures a complete and real-time view of activities across the network. Third is data storage. You can see this part. After the collection, data is stored in a secure database. This storage enables long-term analysis and pattern learning. Next, fourth step, it is a main step, which is the data analysis. This is where machine learning kicks in. It is basically split into three parts. First is signature-based detection, second is anomaly detection, third is a machine learning algorithm. So first we look at signature-based detection. Basically, it works like an antivirus. It matches known attack patterns. It is efficient for threats but not great for new ones. Like if a previous attack is happened, it will detect, but if a new attack is happening, we cannot detect it. Second is anomaly based detection. Basically, this part uses machine learning to detect abnormal behaviors that don't match normal usage. And we can flag unknown or zero-day attacks. It is basically trained over time using historical data patterns. Third comes machine learning algorithms. It powers anomaly detection by learning what normal behavior look like. It continuously improves by analyzing new data. And third is it helps predict and detect subtle threats in real time. Okay. Fifth is rule database. All the known roles and patterns are stored here. The anomaly detection component updates this database with a new threat signatures over time, making the system smarter. It is basically the database from which ML model learns. Now sixth comes anomaly and rules output. Based on the detection and alerts, based on the detection, basically alerts are categorized as either rule based or unknown. Okay. Seventh is this part. Seventh is visualization. Basically, results are shown through dashboards, report, and email notifications. In dashboard, we have real-time metrics and alerts. In reports, detailed incident logs and trends. In in email notification, immediate alerts are sent to the security team. Last comes user Last comes user action. Now the user will take the required action. Finally, the security team investigates and responds to alert. This could mean blocking an IP, disabling a user account, or starting a deep forensic investigation. So, this entire workflow basically demonstrates how machine learning enhances cybersecurity by enabling systems not only to detect known attacks but also predict and identify unknown threats. After this, we'll talk about machine learning in healthcare. Now we'll shift our focus in healthcare, an area where machine learning is literally saving lives. So, in healthcare, machine learning is driving innovations at a very good pace. First, for disease diagnosis, machine learning algorithms can detect patterns in patient data, like blood tests or genetic sequences, to catch diseases early, even before some symptoms fully develop. Second is medical imaging is another area being transformed. Machine learning enhances the accuracy of scans like X-rays, MRIs, or retinal image. And third is we are going to talk about a case study about Google's DeepMind, which is a trained neural network to diagnose eye diseases using retinal scans. It matched it matched or even outperformed human doctors in some cases. It is so well trained. It has outperformed human doctors as well. Now we look at a simple diagram that illustrates how multiple AI agents can work collaboratively in the healthcare sector, interacting with the both doctors, administrators to automate and optimize tasks. First is a doctor. The starting point for the patient care. The doctor interacts with several AI agents to streamline workflows like accessing records, setting appointments. Second is medical records AI agent. Basically act as a digital assistant for handling electronic health records. It basically helps the doctor quickly retrieve, update, and analyze patients' medical history. Third is appointment scheduling AI agent. It basically coordinates with the doctor's availability and patient's preferences. It basically automates appointment booking, reminders, and rescheduling. Fourth is healthcare AI agent. It basically functions as a central brain. It connects all AI agents. It ensures smooth coordination between medical, administrative, and compliance tasks, and basically acts as a middleware that enables intelligent decision making and task assignment. Fifth is healthcare administration in the top right section. Here we can see the healthcare administration. It basically handles the non-clinical operation. It collaborates with AI agents to reduce manual workload. Sixth is medical compliance AI agent. It ensures all the practices follow health regulations and standards. It automates audits, flag non-compliances issue, and keeps records that sound legally. Okay, it keeps the records legally sound. Last is billing AI agent. It manages insurance claims, patient billing, and invoice processing. It basically takes part of the billing. Okay, ensures timely payments and accurate record keeping. So, the network of AI agents demonstrate how automation can significantly reduce human workload in healthcare by handling repeated tasks and high volume tasks while enabling faster and efficient care delivery. And this was how ML is implemented in healthcare. Next topic. Now we'll talk about ML in smart cities. ML is playing a pivotal role in making our cities more livable and efficient. Now we'll see how ML is implemented in smart cities. Smart cities depend on real-time data and machine learning helps make sense of all that data. First is traffic management. Traffic management is a great example how machine learning models can predict congestion patterns, read out traffic, and even control signals dynamically. Second is energy efficiency. Basically benefits all by monitoring usage in real time. ML systems can adjust lighting, heating, or cooling across buildings to conserve power. And third is urban planning. Urban planning becomes smarter when we use machine learning algorithms to analyze data on population density, public transport usage, and helping government to make data driven infrastructure decisions. So we have the data and we can take decisions based upon that on that data for our infrastructure. So next we'll see a video. So here's a clip that demonstrates machine learning model in action of for traffic management using YOLO and DeepSort to detect, track and count vehicles dynamically. This system can detect, track and count vehicles in real time, helping cities plan better for toll booths, parking spaces and signal timing. So we'll talk about the tech which is used in here. First we'll talk about YOLO. It basically understands for you look only once. It is a powerful object detection model that identifies vehicles like cars, trucks, and buses in each video frame. Second is DeepSort. On the other hand, it is responsible for tracking multiple vehicles across frames, ensuring each one gets a unique ID that sticks with it, and even though crowding and occlusion. Third, what makes the system really cool is the trailing visualization. It draws paths behind moving vehicles, which helps traffic analysts see the flow and the behavior of traffic over time. Basic use case include monitoring traffic congestion at intersections. Second is automating vehicle counts at toll booths. Third is managing smart parking systems. Fourth is enabling data-driven urban planning for roads and infrastructure. Overall, we have seen it is a great example how machine learning helps reduce manual surveillance, improve decision making, and enable scalable traffic intelligence in modern cities. Next, my teammate Anurag will take over.
Look at how ML powers the Internet of Things or IoT. In IoT ecosystem, devices generate constant streams of data. Machine learning can analyze this data in real time to enable automation, real-time analytics, personalization. First, automation. Devices learn user behavior, like your thermostat knowing when you will be home. Second, real-time analytics. ML provides quick insights from incoming sensor data. Third, personalization. Think smart speakers that understand and adapt to your preferences over time. This seamless intelligence is what makes IoT truly smart. Now, moving to the next slide. This diagram illustrates the working of an IoT-based monitoring system using a dashboard for real-time insights. The entire architecture is broken down into four key layers: the edge layer, the connectivity layer, the middleware layer, and the end user layer. So first, let's talk about edge layer. This is where data collection begins. A network of IoT devices and sensors captures physical parameters like temperature, motion, traffic, and flow. These devices act as the eyes and ears of the system. Now moving to connectivity layer. Data is transmitted using connectivity protocols like Wi-Fi or Bluetooth. This layer ensures that the information collected by sensors reaches the cloud or central system securely and efficiently. Now moving to middleware layer, the heart of the system. Here is the incoming data is stored, processed, and analyzed. Machine learning algorithms can be applied at this stage for real-time decision making and predictions. Now moving to end user layer. Finally, all processed data is presented visually through the IoT dashboard, and users such as city planners, administrators, or engineers can monitor trends, generate reports, and take necessary actions based on the insights. Here's a quick case study of use of ML for agriculture. This fascinating application of ML and IoT in agriculture, which is a smartphone-based IoT system powered by TensorFlow, allows farmers to detect cassava diseases offline and in real time using only images of leaves. The model is trained to detect 7 different classes as shown in this image, including A. Healthy, B. Brown streak disease, C. Mosaic disease, D. Green mite disease, red mite damage, brown leaf spot, nutrition deficiency. This empowers farmers to take action quickly and protect their crops, especially in areas with limited internet access. Next, let's explore ML's impact on banking and finance. The financial world relies on accurate predictions and risk analysis, making it a natural fit for ML. These are the three topics which we will be covering. First, fraud detection. ML can identify patterns that suggest fraud, such as unusual spending behavior or rapid account changes. Second, risk assessment. Lenders use ML to evaluate credit risk more accurately. And third, customer insights. Banks use ML to personalize offers based on user behavior, improving customer satisfaction and loyalty. It's like having a financial analyst working 24 into 7 powered by data. This diagram represents the workflow of how machine learning and large language models are being integrated into banking and finance applications. First is data sources. The process begins with collecting rich data from two primary sources: customer profiles and market data. Customer profiles include our user history, preferences, behavior. Market data like stocks, trends, interest rates, and financial news. Second is data pipeline and embedding model. This raw data flows into data pipeline which cleans, transforms, and prepares it for use. An embedding model then converts textual or structured data into numerical vectors, which are stored in vector database for efficient querying and retrieval. Step 3, which is LLM integration. The vector data combined with user prompts is sent to LLMs like GPT or open source models. This is managed through a layer that handles LLM caching, validation, and LLM ops to optimize performance and reliability. Fourth, orchestration, like ZBrain.ai. ZBrain.ai acts as the orchestration engine here. It intelligently routes the inputs and outputs between LLMs, embedding models, and final application. It ensures smooth workflows, handles logic, and appeals necessary business rules. Step 5 is banking and finance app. Finally, the insights from this ML-powered systems are delivered to the banking and finance application. This could include personalized investment suggestions, fraud detection alerts, credit scoring, or customer support automation. This ML architecture ensures that banks can leverage the power of data, AI, and LLM to deliver smarter, faster, and more personalized financial services, closing the loop in the real-time feedback for continuous improvement. Now moving to predictive maintenance. Traditional maintenance schedules rely on time, but machines don't always fail on schedule. Machine learning flips the script by monitoring equipment data in real time to predict when something's about to go wrong. This helps to prevent unexpected breakdowns, reduce downtime, and extend equipment lifespan. From aircraft engines to factory conveyor belts, predictive maintenance saves millions. The diagram explains how machine learning enables predictive maintenance, a key component of smart manufacturing and industrial IoT systems. On the left panel, we have the working, and on the right panel, we have the impact. Let's go about the working. Predictive maintenance begins with continuous monitoring of industrial equipment using embedded sensors. These sensors capture health and performance indicators like temperature, pressure vibration, usage frequency, and more. The collected data is then merged with additional context like maintenance history, equipment, metadata, and ERP systems data to provide a holistic view of the machinery status. Now moving to data flow and ML analysis. Sensor data is streamed in real time, sent to the cloud. In the cloud, the system aggregates all the metadata and historical data. Analytics engines process this data and use machine learning models to detect anomalies, predict potential failures. The system then alerts maintenance specialists through dashboards or mobile apps. Finally, this information is also passed onto shop floors, so action can be taken before a failure occurs. Now moving to the impact. Predictive maintenance can bring massive benefits. It is expected to reduce production asset maintenance costs by 41% and could generate over $631 billion in financial value globally by 2025. It's a leading edge use case in IoT with 56% of organizations already testing predictive maintenance solution. Predictive maintenance transforms the traditional break-fix model into a proactive and intelligent system saving time, reducing downtime, and maximizing operational efficiency. Now moving to the conclusion. To wrap things up, technology and especially machine learning is a transforming way we solve real-world problems, from improving efficiency and accuracy to enabling smarter decisions. ML is at the heart of innovation across industries, whether it's healthcare, finance, transportation, or infrastructure. The possibilities are endless when data meets intelligence. As we continue to explore and implement these technologies, our focus should remain on building solutions that are scalable, ethical, and impactful. Thank you for joining us today. We hope this video gave you a better understanding of how machine learning can be applied to create smarter systems and a better future for all. Thank you.